At this point, we're going to transition over into the tutorials for the day. And just as a general intro to these tutorials, as I mentioned before, we're hoping that these will both enable all of you to feel equipped to participate in the Neon Forecast Challenge, as well as introduce sort of a number of forecast relevant skills outside of the challenge as well. And while we don't really have the time to walk through all of the ecology and data acquisition and modeling for every type of ecological forecast in the couple of hours we have today, we've decided to sort of frame these workshops with one common example, which we're pulling from the Neon Forecast Challenge. And we've chosen to highlight the phenology challenge. So throughout the day, you'll sort of see that these tutorials work together and build off one another to walk through the process of submitting a phenology forecast, from the first step of acquiring the NEON data and the NOAA sort of meteorology covariate forecasts, to actually producing that forecast, to submitting it to the Neon Forecast website that the RCN is hosting. So again, we can't really go into the technical details of, building a model and calibrating a model and all of that. We're sort of going to jump into it with assuming that you have a model, you're an ecologist studying phenology in this case, and you've got a model which you're ready to sort of hand over and transition into a forecast for the challenge in this case. And so that's kind of the context with which we're working for all of these tutorials. Our first tutorial today is going to be given by Libby Mohr, and we're going to focus on reproducible workflows in this tutorial, which we thought was sort of a really important foundation for setting the stage for working with, just working collaboratively and working with sort of these services such as GitHub that allow you to sort of mark your progress as you go and reproduce it, which is pretty fundamental to a lot of forecasting technique. So with that, I think I will hand it over to Libby.
All right, thanks, Whitney. I'll go ahead and share my screen here. And then hopefully everybody can see my title slide. So great. So hi, I'm Libby Mohr. I'm a PhD student at Montana State University, and I'm really excited to sort of kick off this workshop with a brief introduction to reproducible workflows with an emphasis on version control using Rstudio. Oops. Okay, so I just wanted to start off by mentioning that these terms reproducibility and replicability are sort of a confused terminology, and they're used by a lot of different people in a lot of different ways to mean different things. And so for the purposes of this tutorial, when I describe research as being reproducible, I mean that, I mean that an independent researcher or team of researchers could produce the same results using the original code and data. And so in general, reproducible research tends to make the research more credible. It tends to make the scientific process more transparent, which can help build trust between scientists and stakeholders. And lastly, reproducible research is foundational, meaning that somebody can take the original analysis and sort of build upon it by either applying the original analysis method to a new or expanded data set, or by coming up with modifications or improvements to the original analysis method. And so in this way, reproducibility really has the potential to accelerate the pace of our science, which I think is really exciting. I also want to touch on this concept of repeatability, which means that a researcher or team of researchers could reliably repeat their own computation and obtain the same results. So repeatability is really required for reproducibility. You have to be able to repeat your own computation in order for somebody else to be able to do it. And I wanted to mention that here because a lot of the tools that I'll mention here today facilitate repeatability. And so they not only benefit other researchers, but they also benefit your future self as well. Okay, so maybe you're on board with reproducibility now, but you're wondering, how do I actually make my science more reproducible? And so there are lots of different tools that you could put in your reproducibility toolbox, and I've just put a few examples here. So for example, you might use the Dryad repository to publish your data. You might use ecological metadata language for creating metadata, or you might think about using Docker containers to ensure that your code will run on any computing environment. And today I really want to focus on this left side of the toolbox. So I'll start out by briefly touching on project-oriented workflows in Rstudio. And then I'll spend the remainder of the time providing a brief introduction to version control, specifically using Git and GitHub for organizing and sharing your code, as well as for tracking changes and project and progress. But if you're interested in learning more about some of these tools and reproducible workflows in general, I encourage you to check out this, this task view that some folks from FE put together. And I've linked that here, and I'm happy to share these slides after the workshop so that you can access that link. Okay, so arguably one of the most simple ways that you can make your work more reproducible is to use project-oriented workflows. So basically that's just a fancy way of saying that you put all of the files that you need for a given project into a single folder or directory, and you make sure that whatever software you're using, for example, R, knows that this is the top level directory. So one really simple way to do that is by creating a project in Rstudio. And what that does is it automatically creates the directory where you can put all of the files related to your project, or you can use subdirectories if you want. And then it automatically sets this top directory as the working directory. And what this means is that you don't have to use a line of code like this. And this is pretty important from a reproducibility standpoint, because if I share this piece of code with a collaborator and they try to run it, it's not going to work for them simply because they don't have a file path or a directory called Elizabeth Mohr, or at least I hope they don't. And so I recommend not doing this. But then how do you specify a file path name in a way that you could hand off your code to a collaborator and they could easily run it? Well, one option is to use this, this here function, and it's from the here package. And what this function does is it uses a little bit of magic to, it's actually not magic, but what it does is it returns the path name of the current project directory. So in this example, I'm working on an R project called my project, and the here function returns this file path. But if you were to have this same folder on your computer and you created a new project in Rstudio with this folder as your working directory, the here function would return a different file path name according to where the folder was stored on your computer. And so you can also use this, this here function to tack on things to the end of your project directory. So here I've tacked on this subdirectory data and this amazing data.csv file, and it produces this amended file path. And one of the reasons I wanted to bring this function up is because you'll see it, Alexa use it in the tutorial later today. So in summary, by using projects in Rstudio in combination with these tools like the here package, you can pass off this nice, tidy, organized folder to somebody else, and it's really seamless for them to run the code without changing a thing, which makes your analysis overall more reproducible. So now I want to transition into talking about version control, and I want to start off by justifying the need for version control with a bad example that might resonate with many of you, or at least I know it really resonates with my experience before I started using version control. And so imagine you started a brand new forecasting project. And so you make this project in Rstudio and you add a script to your folder called forecast.r. Now imagine you make some improvements to that file and you save it as a new file called forecast2.r without deleting the original forecast.r in case you want to go back later and look at that older version. Okay, let's say then you want to test out some new feature in your forecast, but you want to keep this working version forecast2.r while you test out the new feature. So you make another file forecast2_test.r. Okay, and then finally, maybe let's say you get some edits from your advisor and you save the edited file as a new R script. Now imagine yourself 3 months down the line, trying to figure out which script to continue working on and how all of these files are related. So you might wonder, for example, did I ever get this test version working? Or how is forecast2 different from forecast2_test? Or did I have my advisor edit forecast2, or did they edit forecast2_test? So no worries, you got this. You figure out that you did get your test to work and that your advisor had actually edited forecast2.r. So all you have to do is add the changes from your advisor into forecast2_test, and you'll be good to go. So this is what you do. And to prevent this problem from happening again, you decide to name this new script forecast2_use this one, all caps. And this is something that I have actually can admit to having done something very similar to this. But then you get greedy maybe, and you decide you want to add some temperature into your forecast, and so you create another script. And then 3 months down the line, you have no idea whether to trust yourself and use this one or to use a file that, that looks to have been modified more recently. Okay, so you might feel like that at this point. And as it turns out, version control is really good at preventing a lot of the frustration that I just described. So what exactly is it? Version control is a system that records changes to a file or set of files over time so that you can recall specific versions later. So you can sort of think of it as being analogous to the track changes feature in Microsoft Word, where you can see the full history of changes that have been made. But it's even cooler than that. And by cooler, I mean more powerful and more rigorous. So for example, with version control, you can create new branches where you can test out new features while keeping a working version of your code in a separate branch. And one of the more popular version control systems is called Git, and I'll focus on that today. So when you use Git, you create this thing called a repository, or it's often called a repo for short. And each repository contains all of the files associated with a given project, in addition to each file's revision history. And you can store your repositories in the cloud using a service like GitHub, which is a service that simply hosts repositories. And so you can have what we call a local repository on your computer, and then this remote repository here that lives in the cloud. And this is nice both for peace of mind, your work is stored in the cloud, and also as a means of sharing your code with the public if you so choose. The other advantage of using GitHub is that it really facilitates collaboration. So in this example, there are 3 collaborators who all have local repositories and who can all contribute to this common remote repository. We call that pushing. And then the collaborators can also stay up to date on changes to the remote repository, which is referred to as pulling. So I want to go through 2 demos today. In the first one, I'll create a new R project with all of the code for this workshop by cloning the repository from the FE GitHub. And so you could use this workflow to sort of take the code from GitHub and rerun it after this workshop. And then I'll do a second brief demo where I'll create a new repository using my personal GitHub account. I'll write a script. I'll do what's called committing the changes, and then I'll push them to GitHub. Now, there are a couple prerequisites for going through this demo, some installations and some setups. And so I've put all of those things here, and I've linked to instructions on how to do all those things. So those will be available in the slides afterwards. And then lastly, because this is sort of like a rapid fire version control tutorial, I've just compiled some of the resources that I've found most helpful for learning how to use Git and GitHub with Rstudio. Okay, so now I'll navigate to this GitHub repository. So this is the GitHub repository for this workshop. And so you can see there's a subdirectory for each of the modules that are going to be presented today. And so say I want to take this, this remote repository on GitHub, and I want to have a version on my computer. I want to have a local repository. What I'm going to do is I'm going to do what's called cloning. And I can do that by clicking on this green code button. Okay, and then it comes up with this and it says clone. And I have GitHub set up to use HTTPS. So I'm going to go ahead and keep that selection. And then just click this button to copy the link. Okay, and then I'll navigate over to Rstudio. And what I'll do is I'll click File, New Project, and then I'll choose version control, check out a project from a version control repository. Then I'll choose Git, and then I'll just go ahead and paste that URL that I just copied from GitHub and simply say create project. Okay, so we'll think a little bit. And then you can see that I have all of those subdirectories now in my Rstudio. So I can open some of the scripts from this workshop and I'd be able to run them. And so in Rstudio, there are a few different ways of interacting with Git. One of them is you can use this Git pane. So you can see there are a number of different buttons to do different things. And so I'll just show you briefly by clicking on the clock button. I can see all of the changes that have been made to this repository. And so Git, one thing that it does is it doesn't just track every single change that you make. It makes you tell it when to remember the state of the project. So if you're working on a project and you've made a critical mass of changes, you can do what's called committing those changes. And that basically tells Git, I want you to remember the state of this project right now, and I'm going to commit to it. And usually that commit is associated with a message. So you can see that here. And these messages basically say, this is a summary of what I've done since I made my last commit. And since this is a collaborative project, you can see who contributed that commit and when they committed. Okay, so I'll just go ahead and exit out of that. And then the other way that you can interact with Git from Rstudio is in the terminal, so from the command line. And so I can type something like git status, and it will tell me that I'm on the main branch and that my branch is up to date with the remote repository. But so then let's say that maybe the remote repository got updated. There's some new scripts or some updates to the scripts, and I want them on my local repository. So what I can do is I can click this blue button in order to pull. And so if I click that button, it tells me that I'm already up to date because no changes have been made since I cloned the repository. Alternatively, I can go into the terminal here and I can just type git pull and it will tell me the same thing. So that's maybe a little bit boring, but okay, so now I want to show you how you can make your own repository and commit the changes and push them back to GitHub. So I'm going to exit Rstudio and return back to my personal GitHub. And to make a new repository on GitHub, I'm just going to click this green button that says new repository. You have to name it. So I'm just going to use this suggested name called Probable Journey. And I'll add a little brief description that's EFISA workshop demo. I'll make the repository public so anybody can see it. And then I'll add a little description file. And then I'll create that repository. Okay, next, what I'll do is I'll just do the same thing that I did before. So I'll clone this repository. Click on the copy button. And I'll go back to Rstudio and I'll say File, New Project, Version Control, Git, and then go ahead and paste that link. Okay, so let's say now I have my R project, and let's say I want to add a new script, a new R script, and so I'm going to type some code like print I love ecological forecasting. Okay, and I'm going to save that file as truth. And then when I go to this Git pane, I can see some changes that have been made since the last commit. So I can see that that these files have been added, that I've added this this truth.r file, that I've added this probable journey R project file. And so before I commit these changes, what I have to do is stage them. So in this Git pane, I can do that by just clicking on the checkbox, or in the terminal, if I wanted to do that, I could just use the command git add dash capital A, but I'll do it in this using this Git Pane here. Okay, and then to commit these changes, all I have to do is click on the commit button, and it prompts me to enter a little message. So I'll just say, I spoke the truth about my love of eco forecasting. Okay, and I'll just press commit. Okay, and so it was successful, and it tells me my branch is ahead of the remote repository by 1 commit. So what I can do to fix that is I can push the changes to GitHub. Okay, and now if I go to my GitHub repository and I refresh the page, now I can see my new truth.r file, and I can see my commit message that I have spoken the truth about my love of ecological forecasting. So that's all I have for you today. And if you have any questions about this, I'm more than happy to respond on them. You can message me on the FE Slack, or I'm happy to provide my email if you have questions after the workshop. So thanks.